listen-only mode.
All right, good morning, everyone. Thanks for joining the electrical safety panel discussion today. This event is sponsored by Grace Engineered Products. The panelists here we have is Dr. Jay Prigmore. Jay, can you just give a quick introduction of yourself, please?
Sure. So I'm an electrical consultant. I do a lot of work in electrical safety and arc flash. I am a member of IEEE 1584. And I just joined the IEEE's SCC 18 committee to help provide some comments on the NEC and NFPA 70E. I do a lot of work when it comes to post-accident investigations, such as when there is an arc flash or there's an electric shock event. I would come in there afterwards and play detective and try to figure out what happened and how to prevent things from happening again.
Awesome. So then the call is today again another panelist, Charlie Miller. Charlie is electrical safety consultant. Charlie, can you just give a quick introduction, sir?
Yes, good morning. I'm Charles Miller. I live just outside of Nashville, Tennessee.
I write electrical books and used to write magazine articles. I had to stop because of just covered up. I teach National Electrical Code and NFPA 70E. I'm on the 70E committee.
Awesome. And the other panelist, it's me, Banu Srila. I'm the Technical Product Director with Grace Engineering Products. My background is electrical engineering, and I have experience in electrical power generation and distribution systems, and also represent the UL committees for standards technical panels for 61010 and 1436. With that, let's go to the next slide. A quick disclaimer here. So just want to make sure that I read the disclaimer out. The responses to the questions and the views and opinions expressed during this webinar, electrical safety panel discussion, are those of the speakers based on the professional level and personal capacity, and does not reflect the position of the organizations or other committees they represent. The recommendations and any suggestions provided during this webinar session are purely for informational purposes only and cannot be used in real-world applications without a detailed analysis and written authorization and consent from the presenters. By participating in this discussion or the webinar, the attendees consent to waive all the liabilities arising from the use of the information presented and any misuse of the information that could potentially result in personal injury, damage, or any other negative consequences on the presenters and the organizations they represent. Okay. Let's go to the next slide. So additional information, all the questions submitted along with the registrations will be answered first as we go through the discussion today. And also as you go through this presentation or these discussions, you may choose to submit the questions using the dashboard or the console on your webinar screen, and we'll answer them as the time permits. We have an hour and a half for this discussion, and we'll hope to answer most of the questions. And all the attendees will receive the CEU certificates for the attendance based on the tracking of the number of hours or the time they spent based on the registration and the attendee criteria. And also lastly, please remember to take the exit survey and provide your feedback at the end as you conclude this presentation as well. So with that, we're gonna start a small brief video for the sponsor, Grace Engineered Products, on the permanent electrical safety devices. Okay, so the first question we have here is how to mitigate effects of sweating while wearing arc flash PPE, that is decreased natural resistance, reduced grip, speeding fatigue, etc. Charlie, I think this question is for you from your experience.
All right, we don't have the question up on the screen. Can we get the question up on the screen?
I think there's a question up on the screen, yes. Nick, can you just go to the slide 4, click on the slide 4.
Okay. Yeah, let me get back up to this. Sorry. All right, so with clothing, PPE out there now, it is so much better than what it used to be. The clothing is lighter weight. And in fact, if you haven't seen some of the newest clothing, it's highly recommended you take a look at it. Years and years ago, when I started teaching this, I had an arc-rated shirt, an FR shirt, which we typically used to call it. It was still arc-rated, but it was like, and I still have the shirt, but it's like wearing starched burlap. The clothing now they have long sleeve shirts that are like actually a thin cotton t-shirt. The company that makes the arc flash suits and arc-rated coveralls. In fact, I'll show you in a little while the arc flash shields. They have arc flash jacket like this jacket that is very lightweight. And if we can have our people wearing lightweight clothing, it's going to help tremendously with having to be in a hot environment very long. They also, items such as Oberon's, and I know other companies make it as well, but they have a fan that's inside the hood as well. So I think getting the right equipment, getting the right PPE is imperative. There's still going to be times when people are hot. And of course, our main theme in 70E is to turn it off and lock it out, put the equipment into an electrically safe work condition, and then your employees will not be having to be in this PPE for very long.
Sounds good, Charlie. So do you want to add anything, Jay, on that effect?
I'm okay. Charlie did a good job.
Awesome. So the next question is, so this is for you, Jay. What do you have? Is how does newest revisions on IEEE 1584 affect the arc flash calculations? I think this is right under your wheelhouse. So.
Yeah. So for those who didn't attend the other great webinar a couple months ago on IEEE 1584 updates, but basically the calculations have been revamped. They require a lot more data to like a lot more informational data to gather to perform these calculations, such as the electrode configuration, and based on some of these different data points, the 1584 calculations the 2002 may have overestimated or may have underestimated the newly updated 1584 2018 equations. So basically, the new revision can reduce the arc flash incident energy, or it can increase the arc flash incident energy for the same installation based on a particular installation configuration.
Okay.
And yeah, if you want more details, I'd say go either contact me or go watch the webinar from a couple of months ago detailing the specifics of IEEE 1584.
Perfect. That's good answer, Jay. Let's go to the next slide and look at where can I find the safety standards relating to the intrinsic barriers and distances from gas metering. I mean, we're not really sure about the specific standards, but the good place for you guys to start with would be the UL standards, which is UL 613, which defines the certification requirements for the Class 1 DU2, Class 1 DU3 are the zone requirements for most of the oil and gas and the hazard location applications. And also you can look at NFPA 496 for the reference. Those gives you more information about the safety standards on any of those oil and gas requirements as well. Let's go to the next slide. Is a second AFHA label required for when using a maintenance or safety switch, altering the PD characteristics? I think this is more for you, I guess, Jay.
Yeah, so the AFHA is the arc flash hazard label. So the question is, you know, if we put our equipment into a maintenance mode or a safety switch mode, which alters the protective device characteristics, such as it reduces the instantaneous pickup from times 10 to, say, times 4, does that require an additional label? The short answer, I would say, is if it reduces the instant energy, the answer is no. If it increases the instant energy for some reason, I would say probably you would want that highest instant energy label to be there on the panel. Commonly, I do see a second label on equipment that says label A is for normal operation and label B is only when the equipment is put into maintenance mode. So is it required? Say unlikely unless you are increasing instant energy, but I do see it as a common industry practice that people will add a second label on their equipment if they have the maintenance mode capability.
Okay. Sounds good. So let's go to the next question. For HVAC technician working on the low voltage control side for testing and troubleshooting required to wear arc-rated clothing? And to follow up with that is, can insulated tools, that is test probe without gloves, be used as long as the uninsulated hand is outside the restricted approach boundary? I think this is for you, Charlie.
All right, let's talk about the first question, HVAC working on low voltage control side. And whenever we're dealing with electrical, what is low voltage? I'm going to say less than 50 volts. So let's say it's 24 volts. There's another question later dealing with 24 volt controls. So let's say this is the 24 volt controls. And well, when the HVAC technician opens the cabinet, opens the panel, is it only 24 volts that are exposed, or is there 208 or 480 volts that are exposed as well? So it really depends on the voltage. If it is just low voltage, and if there's no other dangers, then, and we'll talk about this later, there's another question or two coming up about this. So then you would not be required to wear arc-rated clothing. 70E says when an employee is working within the arc flash boundary, he or she has to wear protective clothing and other PPE in accordance with 130.5. So if someone is within the arc flash boundary, say they've opened the cabinet up, there's the low voltage control, but there's also live electrical in that box as well. What is the arc flash boundary? Say even if the arc flash boundary is 12 inches, then someone's hand, if they're going to be within 12 inches, then the hand has to be protected against the arc flash. All right, then the next question, can insulated tools, that is test probes without gloves, be used as long as the uninsulated hand is outside? All right, so if the hand is outside the restricted approach boundary, well, unless the you're going to have really long probes on the test instrument, because otherwise at anything 208 volt or over 150 volt up to about 750 volt, the restricted approach boundary is 12 inches. So if the hand is within 12 inches, then that is a shock protection is required, therefore rubber gloves with leather protectors. Also, 70E has a definition of working on. Definition of working on energized electrical conductors and circuit parts in Article 100 of 70E says that someone is intentionally coming in contact with energized electrical conductors and circuit parts with the hands, feet, or other body parts with, and this is the important part, with tools, probes, or test instrument, regardless of the personal protective. So even if you're holding probes, you are working on the equipment. And just where is the restricted approach boundary? Where is the arc flash boundary? All of that is important.
Wow, that's a great explanation, Charlie. Yeah, that's a very nice answer to that. That's so detailed, right? The 70E defines everything very clearly on the time. So let's go to the next question. I think this is, again, the follow-up to the previous question, I guess. Is it acceptable to have a three-phase low-voltage supply in a panel with 24 volts DC controls, PLC, etc.? And the follow-up is, can you work in the live panel? I think it's a two-part question. I think, Charlie, I will give my input on the first part, which I think from the 508A standards, you can have a three-phase supply in a panel where you have a 24 volts DC controls, as long as you have a completely separated or isolated three-phase low voltage supply, which is, I'm assuming, 480 volts in this case. You need to be completely isolated from your 24 volts DC circuits. And if you're having that, then you need to make sure that specific circuit is logged out and there is no, it's de-energized before it feeds anything to this low voltage compartment. And then in that case, you can work live. However, if it is not, then it has to be completely de-energized before you work on the panel. What do you think, Charlie?
Let me add a little bit to that, the 24 volt DC controls. And Bono's exactly right. They do have to be separated if they are class 1 or class 2. And for this, you go to the National Electrical Code, Article 725. And there's, it's a very interesting article. And it tells us about separating class 2 and class 3 from regular building wiring or class 1. As an electrician, I always thought that Article 725 was, quote, low voltage. Well, it's not. It's class 1 can be up to 600 volts. And there's even a section in Article 725 that says, all right, if you have a class 2 or class 3 volt power supply, you can scratch out, you can mark out the class 2 or 3. That's amazing. It tells us, oh, you can mark it out. But what it goes on to say is, when you mark that out, it automatically becomes a class 1 by default. Well, with class 1, you have to wire it with regular building wire, 600 volt wiring. And going back to the part where we're talking about working on this live, unless there's another problem, and this is going to come up later with energized work and the reasons why we can work on something energized, if it's less than 50 volt and there's no additional hazards, then we're going to be permitted to work on it energized. But kind of giving you an idea of what we're going to talk about when we get there, how close are you to the 208 volts? How close are you to other voltage in this same equipment? If you're going to be within the restricted approach boundary while you're working out on the 24 volt controls, in fact, if you are within the restricted approach boundary and you're working on the 24 volts, you are going to have an energized electrical work permit because you're within the restricted approach boundary, even though you're working on something else. If you're within the arc flash boundary, you have to be suited up for arc flash.
Sounds good. Yeah. Thanks, Charlie. Let's go to the next question. Have there been improvements to the methodology discussed in Annex F of NFPA 70E regarding the risk assessment procedure? Charlie, I think You can answer this question.
Informative Annex F, which is risk assessment and now risk control, this was revised greatly in the 2018 edition of 70E. And I think it has been made simpler to go through and to determine the risk, to use the matrix that is up there. So it's still, of course, anything in the informative annexes is just information only. But when we're required to do a risk assessment, this is a great place to start.
Okay. Thanks, Charlie. So the next question is, what are the standard wire colors for voltage or phase? Is there a standard definition, Charlie, for the?
I think Bono put a lot of my questions right in a row here, which is fine. I'm used to talking. So what is the standard colors? A lot of times when I'm teaching either the National Electrical Code or I'm teaching 70E and I'm teaching electricians and maintenance people and engineers, I ask, what are the required colors for 120/208 volt three-phase? The general answer comes out: black, red, blue, and white for the neutral or the grounded conductor. I say, okay, then what about 277/480? What are the required colors for 277/480? And the general answer comes out: brown, orange, yellow, and gray. Well, the certain colors are required in the National Electrical Code. Our grounded or neutrals have to be white or gray, and we have some other options there. But the required colors as being black, red, blue, and brown, orange, yellow are industry standard only. They are not requirements in the NEC. Now, we do have requirements in the NEC. If you have a three-phase, four-wire delta connection, a delta connected system, the high leg has to be color-coded orange. If you use blue color wire in an intrinsically safe system, you cannot use blue otherwise. But we have to be careful of these industry standard colors. I have heard that there's a plant in North Carolina and other places as well where those industry standard colors are exactly opposite of normal, which an electrical contractor coming in as a contractor, the host is going to have to let them know, we have something here that is not standard. So they have to tell them about the color coding that is in that plant. If I'm so used to black, red, blue, and white being 120/208 and brown, orange, yellow, and gray being 277/480, if I were to go in a plant and I would see black, red, blue, I would almost automatically, of course I wouldn't, but I would almost automatically think that that's 120/208, but it is not. So the National Electrical Code gives us standard wire colors, but what we normally think of 120/208 and 277/480, these are not required colors. Now, the 70 or NEC says that if you have two different electrical systems in one enclosure, then you have to mark and have to label, have to have information that shows the two different color coding systems. And sometimes I'll hear someone say, well, we never have those two in the same enclosure. And I go, wait a minute. Do you have 480 volt in and then you hit a transformer and then out of the transformer you have 208 volt three phase coming out? And yeah, they have that. Well, you have 480 and 208 in the same enclosure in a transformer.
That's a great summary for that question, Charlie. And just to add to Charlie mentioned one point about having this color codes reversed at one of those facilities in Nashville, and then whenever you involve a contractor to perform the work, it is definitely the employer's responsibility or the facility owner's responsibility to ensure that they give the handoff and the document that they're giving enough information about the equipment or the systems ahead of time so that the people who are coming to perform that work are getting a good information about the background of that facility and their infrastructure. Okay, with that, let's go to the next question. Please summarize the 3 conditions where you are allowed energized work. And that follow-up is there a need for energized work permit for working under 50 volts? Charlie, I think this is your question too again, because it falls right on the same thing. So.
All right, so energized work. We need to look at NFPA 70E. Of course, NFPA stands for National Fire Protection Association. The document number is 70E. NFPA has over 300 codes, standards, and recommended practices. And so we're going to look at 70E, and we're going to section 130.2A, which is titled Energized Work. Energized work is permitted for 3 reasons. Additional hazards or increased risk, infeasibility, and number 3, equipment operating at less than 50 volts, not 50 volts and less than 50 volts. And this section 70E, 130.2A, 1 and 2, there are plenty of examples of additional hazards. Would be like if you're working in a healthcare facility like a hospital, where if you turn off, go to an electrical equipment room and have to turn off the whole panel, you may be turning off life support equipment. Infeasibility, an example, and it has more examples there. And feasibility example is, all right, if you're troubleshooting, you might need that equipment energized in order to do your troubleshooting. And so that would be allowed. And then the 3rd one, equipment operating at less than 50 volts. The question about is there a need for energized work permit for working under 50 volts? Let me give you this. 130.2A3 says equipment operating at less than 50 volts, that's the title. Energized electrical conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized, meaning it's not required to de-energize. It goes on. We can't just stop there. It goes on to say where the capacity of the source and any other overcurrent protection between the energy sources and the worker are considered and it is determined that there will be no increased exposure to electrical burns or to the explosive due to electrical arc. So you can't just say, oh, anything and everything less than 50 volts. We have to look at the other parameters to that section. Is there anything else that could increase the hazard that could make it dangerous? Also, we have to be careful with this one. If you're working, I mentioned this a while ago, if you're working within the restricted approach boundary, although you're working on the circuit conductors and parts that are less than 50 volts, if you're working within the restrictive approach boundary, then an energized electrical work permit will be required. And for this, you want to look into detail at 130.2B11 in 70E, 130.2B11.
Awesome. That's a great explanation, Charlie. Only one point I would like to add to your comments is you mentioned everything about where it's allowed in the energized work. I can just only tell about where it is not allowed, or the places where you can demonstrate economic loss or financial loss because of the production pressures. You don't want to shut down the client, so you want your worker to go and perform the live work. Definitely that is not allowed as energized work. Is that right, Charlie?
Yes, and there are other examples in there. In fact, the examples that are given say such as, and they give some examples. Also, I think we've got a question coming up later about continuous process, such as steel making or glass making. And I was working in a plant or teaching in a plant in Crossville, about an hour and a half from home in Tennessee, halfway between Nashville and Knoxville. And they have an area that they would consider to be continuous process, where they are the tiles, ceramic tiles, are going through a kiln that is hundreds of feet long, that and if they just stop that midway, these tiles are going to burn up, and it's going to cause a big problem. Now, all of this, the employer is going to have to demonstrate that working on this energized is permitted. And if going back to 7D, if you're going to do work on energized circuits, unless it's less than 50 volts, then you're going to have to fill out and use an energized electrical work permit.
Sounds good. Okay, let's go to the next question. I think this is more on both Jay and Charlie. The first question is, what are the top 3 most misunderstood facts related to electrical safety, as in the 3 things every safety training must include? And the follow-up question is, what are the top 3 mistakes or errors and which could lead to or cause an electrical injury? So the first question, Charlie, you can answer, and probably the second one, Jay, you can take. Go ahead.
I don't know that I'm going to go about the most 3 most misunderstood. I think the most misunderstood piece of information out there is that workers, maintenance men, electricians are not, they do not realize that the cardinal rule is it is energized until you establish and verify the equipment is in an electrically safe work condition. I hear quite often when I'm teaching, oh, our people, we don't do any live work. Well, okay, that's fine, but until the equipment is put into an electrically safe work condition, you have to consider it energized. That means until you have established and verified, there are 8 steps in establishing and verifying the equipment is in an electrically safe work condition. Until you have done that, the equipment is energized. You have to treat it as energized, and that, I think that is absolutely the biggest. All right, another one, it's just, and when I'm teaching, and what I've even started doing the last several years is doing hands-on training. I'll have a seminar one day, and the next day I'll do hands-on training. One of the things that is probably the most forgotten step is after you have tested it, and this is testing for the absence of voltage, and it's sometimes called live dead live test. You test for the absence of voltage. You test the tester to begin with on any known energized source. And Fluke makes a product. Now, I don't sell any of these products, but when I find products that I like and that I know are great for electricians and maintenance people out there, then I'm going to show them. Fluke makes what they call a proving unit, and this proving unit it has 2 contacts where you use this to test your tester. And it's AC or DC, it's 4 AA batteries. You test your tester to make sure the tester is working. Then you test for the absence of voltage. How do we do that? Test phase to phase and phase to ground of all the conductors and circuit parts. And a lot of times when I'm doing the hands-on training, the electrician or maintenance people or whoever, even safety people that I'm working with, they want to put down the meter at that point, and I'll say, oh, wait a minute, is your meter still good? And just a couple of weeks ago, I had someone say, oh yeah, it's good. How do you know? Well, the lights are on. No. You've got to live dead live, test for the absence of voltage, test the tester, test for the absence of voltage, and test the tester again. That last test the tester again is one of the things that a lot of people miss in the actual hands-on training or the field, even the field work audit that is a requirement in 70E.
Okay, that's good. So Jay, what are your thoughts on the top 3 mistakes or errors as you go and look at some of those investigations and field side of it?
Yeah, so before I start that one, I just want to say that I agree with Charlie on answering the first question. I commonly see those even in people who do investigations and are supposedly electrical safety experts as well. So going on to the next, what are the top 3 mistakes or errors? I would say there's a combination, but typically rushing. Someone's rushing to try to get the equipment back up in service, and that could be due to pressure. Their management is pressuring them to get the equipment running again. And the third one I would say is comfortability/carelessness. So this is somebody who's been working on the equipment for 5-10 years and knows it like the back of their hand. Well, they're just they think they know it all, and then they kind of let their focus slip a little bit. And when they let that focus slip, that's when they get hurt. So those are the three things that I would say is that would lead to it most commonly from what I've seen.
That's good. And to add to that, I think maybe that's the reason why NFPA 70E identified the human error as one of the reasons, to just align with what Jay has just stated, right? So people get complacent, and then production pressures and such. So that's why they included the risk assessment procedures, and also if you look at the risk control hierarchy chart, which is on the cover page of the 70E context, which talks about the different elements where you can look at elimination, substitution, and engineering controls, where you can minimize those as well. Okay. Let's
and one thing
go to the next question.
Hold on one sec. One thing that I've also seen is the failure to recognize all known voltage sources or all known power sources. So someone will go into a panel and just disconnect the main disconnect switch or the main breaker and say, okay, everything else downstream is in this panel is de-energized. A, the incoming conductors are not de-energized, and B, there could be another known source or a source that's unknown, such as a capacitor or a secondary feed of power into that panel that back feeds into where they're working. And they'll just isolate that one breaker, and then they'll go in and do their live work, and they'll get shocked or electrocuted because of their failure to recognize all known or all available power sources.
That's a great point. I think that brings up one of the discussions what we have here at Grace is Grace Sports, where people think is programming a PLC. They think that they're only getting interacted with that piece of low voltage 24 volts DC, but they're not understanding what is adjacent to that, like a 480 volts or anything 277, which they might get accidental contact with. That's why Grace Sports are some of the products where you can conveniently access those safely from outside the door. So just a thought. So let's go to the next question. I think this is for you, Jay. How often should we carry out the fixed electrical wire testing, and what routine check? And then the next question is, why do people sometimes freeze when they're shocked? I think I get sometimes surprised too, looking at the people getting freeze. So
yeah. So to answer the first question, this is a very first off, it's very vague and open-ended. I'm assuming when you mean like electrical wire testing, you're looking at maybe like insulation resistance testing or high pot, or even say pressure connection testing, like making sure that there's a solid connection between one conductor and bus bar or between conductors. And I would say follow the manufacturer's recommendations on when and where and how to test. And frequently, I commonly see between anywhere between 1 year and 5 years when it comes to performing standard maintenance on electrical equipment. And it's all based on what the manufacturer recommends on when you should do testing. And it's all based on your environment and your operations and just basically how you utilize the equipment. So if you're utilizing the equipment at 90-95% capacity versus utilizing it at 30% capacity, there's a lot of extra heat when you talk about current going through it, and that may negatively impact the wire insulation and reduce the expected life much more than it would at 30%. So I think checking it maybe a little more frequently on the 90% scenario would make sense versus checking it at 30%. So that's something just to keep in mind. There's not one specific fixed answer for that question. And then to answer the second question, why do people sometimes freeze when they're shocked? Well, this has to go into with muscle contractions. And basically what happens in layman's terms is when you have electricity flowing through your muscle, what it does is it contracts the muscle. And you essentially just freeze. And there's enough current going through there that you can't let go and you can't open up you can't basically open up your hand. A lot of times whenever when you freeze, it also prevents you from breathing. So it just kind of depends on where it is. But basically, the short answer to why they're freeze when they're shocked is because the electricity flowing through their muscles causes the muscle to contract, and they can't reverse that contraction.
It's true. And also, OSHA defines something on their articles about 4 to 6 milliamps. Is that right, Jay, as a threshold?
Yeah, it's about 5 milliamps is one of the common numbers, but you know, you can happen even lower. There's an IEC curve. I forget the number, but there's a curve that shows regions on where it's if you conduct like less than a milliamp or so, you would be it's imperceptible, so you can't even feel it. And then there's another section of the curve where it is perceptible, but you still control your muscles. And then there's another section of the curve where it is perceptible, but you cannot control your muscles. And then based on time and duration, you can also get into like cardiac arrest. So there's about 4 or 5 regions, if I remember correctly, that kind of show based on current magnitude and duration on where you would lie in that curve and what your body response typically can be.
Thanks, Jay. So let's go to the next question.
Let me add something to that, Banu. I went through an electrical apprenticeship program years ago not that long ago, actually, it was years ago in Nashville, Tennessee. One of the things I heard in class, and a lot of electricians and engineers and maintenance people have heard this, it is absolutely not true, but I heard that if you're going to test something electrical, then test it with the back of your hand, because your muscles will contract. That is absolutely not what we are to do. That is just some of the things that I heard when I was an electrical apprentice. And in fact, when I'm teaching class electrical safety, NFPA 70E or OSHA electrical rules, I'll let people know right off the bat that I am the poster child of things not to do when it comes to electrical safety, or at least I was the poster child of things not to do when it comes to electrical safety. And unfortunately, there are, it's getting better, a lot better, but there are still people and places that are just not respecting electrical. They're not using electrical safety. And one of the questions that was talked about a while ago are mistakes that are made, and just thinking that, oh, it's not going to happen to me. And I don't hear this as much anymore in classes, that electrical safety classes, but it doesn't mean that it's not in their head when I'm teaching that, oh, this isn't going to happen to me, I shouldn't have to do that. But it can happen to anybody, anytime, anywhere.
And all it takes is once, sometimes, right?
Yes.
So let's go to the next question. I think, again, this is for you, Charlie. What to do if you don't have other choice than to work with live circuit, risk factor of working with live circuits, risk factor of working with live circuits? That's a question. All right.
This is a huge, it could be a long drawn out question, but let me point you to the right area. And we talked about it a little while ago. 130 in 70E, 130.2A talks about and covers energized work. And so getting down to the point that if you are working on something that is energized, then the employer is going to have to demonstrate or have to prove that it's okay to work on that energized. And then if someone works on it energized, then they're going to have to fill out and use an energized electrical work permit. I heard a statistic years ago that companies that have started using energized electrical work permit, the energized work dropped 70%. It didn't drop to a level which is 70% of what it used to be. It dropped 70%. So it was now 30% of what it used to be. And you can understand this because if there's a supervisor or somebody high up that is saying, oh, you have to do this work, it's energized, and so, okay, then the electrician, the maintenance person, the technician, I'm going to fill out this energized electrical work permit and put on here all the reasons what I'm going to do, and in the back of 70E, there's a good sample energized electrical work permit. And then when it comes down to the very bottom, you get somebody as high up as possible to sign it. Well, the manager, the electrical supervisor, the plant manager, the safety director, you try to get somebody like that to sign off on that, and they don't want to put their name on that, because what if something happens? Then they're saying, oh, I knew it was dangerous. I knew that it was okay for this person to work on this live energized circuit, and I signed off on it. No, but people are not, we don't want our signature on a paper, something like that. So that we have to be careful that about doing energized work, and does it meet one of the 3 allowances in 70E? Now, let me mention, OSHA they have those 3, plus they have a 4th one. The 4th one, OSHA says, if you turn off the circuit and it eliminates all the lighting in the room, then it's okay to leave the electrical on. This is not in 70E. And if when OSHA ever updates their electrical safety rules, guarantee that's going to come out. And so, because now we can bring in temporary lighting, we have battery powered lighting, we have light, just whether extension cords or bringing a nice 18 volt Milwaukee battery power, light stand. I mean, there's lots of things we can do. So turning out the power in an area is not an acceptable means. Okay, what are the risk factors of working live circuits? Well, shock. Shock would be injury or death. Arc flash, arc blast, injury or death as well. So yes, these are the potential, and not even counting. These are the 2 main ones. Not counting something like if you're up on a ladder and you get shocked and fall off. The fall, of course, if you're above a certain height, you should be wearing fall protection as well. But there are risks, and I know Grace. I saw their pyramid, which it's similar to the pyramid. The words are the same with the pyramid on the front of 70E, but their pyramid is upside down. Grace drew their pyramid upside down, which I think is great, because, and I also do illustrations, and I drew my pyramid upside down as well, because when you're looking at something, you usually look for the broader area, the bigger area, then you narrow it down, narrow it down, narrow it down. And if I do that with the 70E pyramid, then if I look on the bottom, first of all, I'm going to work live and wear PPE. And when all else fails, I'm going to eliminate the circuit. No, that's exactly opposite. So I like that, Banu, I like that you or Grace has flipped that pyramid upside down, because I did the same thing 2.5 years ago, 2 years ago, when I put my program together for PowerPoint for 70E.
Thanks, Charlie. So let's go to the next question. I think it's again for you, Charlie. Is it okay to have equipment located and the electrical disconnect that power it? It's more like NEC question.
This is a National Electrical Code question, NEC. And when I'm teaching, NFPA, National Electrical Code, is document 70. If you look on the lower left and right pages, it'll have the page number, but in National Electrical Code, it would be 70- in the page number. It's very similar to 70E, except 70E has 70E dash in the page number. So the document number we're talking about is National Electrical Code. When I'm teaching, I will ask anybody in the class if they have older editions or an old edition of the National Electrical Code. And usually, almost always, one or more hands goes up, and I say, okay, don't ever throw away an old copy of the National Electrical Code. And they kind of look at me, and I say, you can sell it to anybody who's having trouble sleeping. And then I'll say, a couple of weeks ago, my wife and I were in Target. We were over in the pharmacy section, and I looked up and saw a tag that says what's in that area. And I saw sleep aids as the tag, and I looked down, and they were selling as sleep aids copies of the National Electrical Code. And then, of course, I get weird looks. I get people laughing, and I say, well, no, I'm just kidding. Well, I have been telling this joke for 10 years or longer. Finally, a few months ago, I was in Target, and I saw the tag that said sleep aids, and I took a picture. And then I got back to my house and I stacked up a bunch of code books and I took a picture, and I'm pretty good with Photoshop, which is, I use Corel. And so I cut out the picture of the code books and put them on the picture of that was in Target, and shrunk them down and stuck them right right on the top shelf. And I stuck it on LinkedIn if you ever wanted to find that. And it's I had over 22 or 23,000 views of that. So anyway, all right, kind of a long story into this. National Electrical Code, putting electrical disconnect or electrical equipment under a disconnect. We have to be careful of Article 404, 404.8, which covers accessibility and grouping. And it says all switches and circuit breakers. Basically what this is saying is the center point of the handle of the disconnect can be no more than 6 foot 7 inches above the floor or working platform. And so we've got to be careful as long as the disconnect is up and no more than 6 foot 7 inches to the handle, the midway of the handle, then it's fine. And we're seeing this more and more in industrial control panels, where there's a disconnect put in front of the industrial control panel. That way, when you turn off power, you're turning off the power going into that. You can open the cabinet up, and once the equipment is in an electrically safe work condition, then you can take off PPE. What has happened, what I see again and again, over and over all the time out there, where the industrial control panel has a disconnect, usually in the upper right corner, disconnect that you can turn the breaker on or off, but the conductors coming in the top are still energized on the line side. And so we have to be careful of that, in that, again, if we're going to work within 12 inches of that energized part, the conductors, we have to be suited up. We have to be, in fact, if you're in the arc flash boundary of the conductors in the top, you have to be suited up for arc flash. So it probably is good, but go make sure the installation complies with the National Electrical Code.
Thanks, Charlie. Let's go to the next question. I think this is for you, Jay. Is there a quick way of choosing PPE without doing arc flash study? I think that's a great question. And also, next question is, if electrical panel installed in a mechanical room, shall people enter the room wearing PPE?
Yeah, so the answer to the first question, NFPA 70E provides a secondary method to determine arc flash PPE if certain conditions apply. And this is called the PPE category method, and it's in accordance with Article 130.7 C15. And basically it says if you have this voltage, this current, and this protective device operating time, this would be your PPE rating. So that can be used as a method to choose PPE. Now that is typically considered a more conservative method than the actual incident energy analysis, because it's a little more targeted and calculated. But that is one method to determine PPE besides a full-on incident energy arc flash study. To answer the second question, if an electrical panel installed in a mechanical room, do people entering the room need to wear PPE? Well, that depends. Depends on a number of things. A, is the electrical panel, is the door closed and is it operating normal? Is there no impending failure? Is the panel across the room from the person and they're outside, say the restricted approach boundary and the arc flash boundary? Are they inside? So the answer to that question is, it just depends on what you're doing. If the panel's door is closed and it's just operating normal, doesn't show signs of impending failure, then no. But if there's potential for impending failure, then probably. And if there's, let's say if the door is open and you're walking right in and you're now violating the restricted approach boundary, even the arc flash boundary, then the answer would be yes. So that depends on your particular situation.
Okay. So that's a good explanation, Jay. I have a follow-up question on that. This is from my side. So what in case if I don't know what is the incident energy level, because my equipment is 60 years old and there's no information, no nameplate details available? In that situation, what is your recommended practice for choosing PPE? I think this probably both Charlie and you can both answer based on experience. So.
Yeah, so one of the things that I would do real quickly is I would look at the PPE category method. What you could do is you could look at the upstream transformer or estimate the short circuit current going into that panel. And based on that, and you know the voltage, you would know if it's been maintained properly or not, especially if you own it. So I would look at that and see if I could get a guesstimate on the appropriate PPE. The other thing you could do is not open the door and not work on anything in that panel live until you get an arc flash study done. So you could put a policy in that says, anytime you're going to work on this panel, you have to put it in an electrically safe work condition, and you just work on it de-energized. So there's a couple options for you.
Okay, thanks, Jay. Do you have any comments, Charlie?
Yeah, absolutely along those same lines. And here I want to promote Grace and their what they call their safe test point, their voltage test station or safe test point. I think this is a wonderful device because this is a device, I don't know if you see it in the background here, where I've got this device installed. The safe test point can go on industrial control panels. It could go on, this would be a great reason to install one on older equipment, where if the company policy says that it has to be de-energized, well, so the safe test point connects to the incoming, or you would put it on the line conductors, the line voltage conductors coming in to the panel. And from the outside of the enclosure, without wearing PPE, you would test your tester. You would test for the absence of voltage phase to phase and phase to ground, then test the tester again. And as long as you've gone through all the other steps, a total of 8 steps, with 7, you might not be using step number 8, depending on the voltage. But as long as you go through all of the steps and having established and verified that equipment is in an electrically safe work condition, and it can be done from the outside. And then you could open up the equipment without wearing arc-rated PPE and shock PPE. Otherwise, if you're getting into this equipment, even if it is shut off, you have to treat it as energized until you have proven it and established and verified that it is electrically safe. You have to wear shock PPE, you have to wear arc flash PPE. And if it's that old, we don't know if it's going to be within the parameters. We don't know. In 70 talks about consider the condition of maintenance should be considered. Is this breaker going to trip and clear in the time that it did originally? And so there's a lot of factors, and so suiting up might be, especially if you're having to get into it where maybe it's a 208 volt panel and normally it might be a category 1 under normal circumstances, as long as the parameters in those tables have been met, then why not possibly wear category 2 or even category 4 PPE when getting in and or testing for the absence of voltage in this panel. And if for the ones of you that are familiar with 70E and its progression over the years, then you will remember we used to have a category 0. Category 0, 1, 2, 3, 4. In fact, even a while before that, we had a category 2 star or 2 asterisk. That category 0 was there, and just turning on a breaker, turning off a breaker, turning on a safety switch or disconnect switch, we had to wear category 0 clothing. Well, category 0 was taken out, it was eliminated, but what came in its place was the term normal operating conditions, and which Jay mentioned some of these. And as long as the equipment is in normal operating condition, no PPE is needed. So it is, if you're, and that's going into this room, as long as everything in the room is in normal operating condition, then wearing PPE into that room is not required.
Thanks, Shirley. I think that's NFPA defines that, what is that normal operation in the Article 130, which we talked about. There's 6 different conditions one needs to meet to make sure that the normal operation conditions are met. So let's go to the next question. I think this question is straight to you, Jay. I think you know of any employer who has successfully defended an electrical injury potential citation using a risk analysis?
Yeah, so this is kind of directly related to my job. I commonly help and look into matters where, say, a company has been cited for their failure to meet certain requirements that result in electrical injury, or the employer is now involved in a lawsuit because the worker is suing the company because of their injury. So I do know of employers who have successfully defended either a citation or have basically had summary judgment on a electrical injury case that's actually in litigation and actually going to a jury and trial. They did a little bit of a risk analysis, but most of the time it is, did they follow the standards? Did the employer do what they were supposed to do in the standards? Do they have appropriate electrical safety plan? And also, what did the worker do? Was he doing what he was supposed to be doing, or was he doing something that he wasn't supposed to be doing? And was he trained? So one of the key things besides just a risk analysis would be to get proper documentation, such as electrical work permits and training of the employees, and a number of potential arc flash study, and giving them the PPE that are required, and make sure that you're on board of what they were doing. So there's a number of things that go into successfully defending either a citation or a lawsuit, and a risk analysis is one of them.
So I think to just add to that, one quick point here, as Jay mentioned, as far as any kind of work that's being performed, any kind of risk analysis you do, if it is not documented, as Jay mentioned, it didn't happen. In the view of any kind of investigations, I think if something is not documented, so it didn't really occur for that instance. So just make sure that whatever the work you perform, whatever the energized work permits you have, just everything is being documented, because when it comes to investigations time, definitely the documentation would greatly help. So the next question to that is a warning label required for equipment where no energized work is performed? What about checking for absence of voltage? I think this is, Charlie, you want to take a stab on that?
Oh, absolutely. All right. Well, with 7D, it says in 130.5 H, 130.5H is the section for equipment labeling. And it says electrical equipment such as, and now this is not an all-inclusive list, it says such as switchboards, panel boards, industrial control panels, meter socket enclosures, and motor control centers. All right, and then it continues with that are in other than dwellings. Well, it doesn't apply to dwellings. Here's it applies to that type of equipment. Again, not an all-inclusive list, but how does it apply? Well, it goes on to read if this equipment, if it's likely to require examination, adjustment, servicing, or maintenance while it's energized, it has to be marked with a label containing the information in 130.5H. And so, which is things like the voltage, the arc flash boundary, and then one of a particular item, either maybe incident energy at the working distance or category, PPE category, but not both. You got to be real careful of that. The new labels that I've seen from the software companies are complying with that. I've seen for years labels that are more than 5 or 6 years old that do not comply with that. But so is a warning label required where no energized work is permitted? Well, all right, energized work is not permitted. If you're going to go in though, how are you going to know that it is electrically safe? Well, you've got to be suited up if you're going to open that equipment up and test for the absence of voltage, or using Grace safe test point on the outside of the enclosure. And I like, it almost sounds like I'm working for Grace. I like this product tremendously because it is a safety device. It can be a lifesaver. And you're testing for the outside, you're testing on the outside of the equipment with test probes, and not only the contacts are safe, Grace went steps beyond that and made it safe that even if you were to stick in paper clips, you're not going to get shocked because of the built-in impedance. So you can do your testing from the outside without opening up the equipment. Now, until more and more places get these installed, we have to open up, or the worker is going to have to open up the equipment, even if it's de-energized, to test for the absence of voltage and to go through our steps of establishing and verifying the equipment is in an electrically safe work condition. So I see a great need of equipment that really needs to be labeled at that point.
Thanks, Charlie. I think we got a lot more questions here. I think we're on the 19th slide, but we'll try to address it as the time permits, as I mentioned before. So next question is, what is the risk of using HRC4 suit for all live work? Charlie.
This is a great question. If it's the older arc flash suit, category 4, it has to be at least 40 calories per square centimeter of incident energy. It has to be rated for at least that much arc rating. A risk with some of the older equipment is it is heavy, it is bulky. And if you've seen some of these suits, it looks like wearing what looks like a bomb suit. That someone's going to defuse bombs. Well, suits have gotten so much better. I mentioned Oberon. I like their products. They are lightweight. They have what they call a true color gray shield, and this is shield. They've got the shield for that works with the hard hat. with the shield that you can raise up. They also have the shield in the full arc flash suit hood, beekeeper's hood. And if you're wondering what this color wheel is behind me, and the reason I've got that up there is if you haven't looked through one of these shields, they are wonderful. This is the shield. You're looking right through the camera, through the webcam, through the shield. And it's called True Color Gray. It does not change the color of items. It does not change. In fact, don't know if I can get this one. I can't really get the shield up there well enough to be able to see through this one is not much. I think it's the same darkness, which is not very dark whatsoever. All right, so a lot of companies for several years, if their employees do not wear daily arc-rated clothing, or some people still call it FR clothing, then what some companies are doing, and what they have done, is they have one duffel bag with category 2 in it, clothing and equipment, and which those coveralls would be good for if it's a category 1 or 2, and they have another bag that is category 4. And then they would use that bag, the arc flash suit and the hood, beekeeper type hood in that, if it's category 3 or 4. Now that we're finding better and better equipment and clothing out there, what I am finding, what I've heard is, and they have different price ranges of clothing, and what I've heard, for example, Oberon, instead of a company that is buying 2 bags, if they just buy 1 bag of the higher quality category 4 arc flash suit, which is very lightweight and has the great hood, then a lot of times they can, which is also easier to get on and off than coveralls, then the companies are kind of going in that direction with buying 1 bag and having their employees use that when working energized or potential energized, as opposed to having the 2-bag system. So clothing equipment continues to get better and better, and I just think that we have some great choices out there right now.
Thanks, Charlie. Hey, Jay, I have a quick follow-up question from the accident investigation. The question is, does the PE stamp enter into the equation during the court case? I think it was a very good question. So,
the PE stamps, yeah. So that's been a topic of debate, even even internally. And basically, the way things are changing is that in these types of investigations, especially when you get into the legal sense, it used to not be required to do any sort of engineering work, like writing a report or reviewing designs and stamping something. I'm starting to see a trend that's changing more to having at least a PE license in the state where the incident occurred, review the work that someone else may do. That way, from the company standpoint, you're kind of protected liability-wise. Many states require a PE to provide, like, say, testimony, or to provide doing any sort of engineering work, which includes writing reports on investigations. So I guess the direct answer is it depends on the state, but I'm starting to see more states
asking for it,
moving towards the requirement of a PE.
Okay. Thanks, Jay. So next question is, please address the changes to the 125 kVA exception. I think, Jay, you can address this.
Yeah, it was removed from the standard, so it no longer applies.
Okay. So do you want to follow up anything on that, Charlie, as far as why and whatnot, or we can just leave it, table that?
It was also removed. There was some, in 70E, we had an exception pertaining to the 125 kVA transformer, and there was some confusion there, and so the committee removed it because Actually, the way it was in 70E was not the same way it was presented in IEEE. And we've gone, and that's been gone for a number of years now, along with our, we also had a default arc flash boundary of 4 feet. That has been changed. 70E has gone through, if you've been following it for a while, it's gone through a number of changes every edition. This new edition that's coming up will be out about a year from September, a year from October. It doesn't have nearly the number of changes as it has been for every edition that we've had for a while. 70E is on a 3-year code, a 3-year revision cycle. The National Electrical Code is a 3-year revision cycle. The 70E is 1 year after the NEC. So when you see a new NEC code book come out, then 1 year from then, when the new code comes out, a new 70E will come out, and thankfully there's not nearly the number of changes in this edition than we've had for every edition for quite a while now.
Okay, thanks, Charlie. So next question is, I think any new technology in place for proactive detection of potential electric fire? So if you're talking about electric fire contacts, there are a lot of arc flash sensors that you can use inside the panel that detects the potential for the arc flash incidents. And also, as you mentioned, we have the hotspot monitors from the GraceSense product line, where you can monitor the temperature rise, which could lead to the potential arc or fire hazards within the panel. You can detect the temperature rise, and you can do a delta T, and you can get the alerts, so you can proactively monitor those. And there are other technologies available as well. So we're not going into the product details. So yes, there's a lot of technologies available where you can proactively detect the electric fire from the electric panels. Okay, let's go to the next slide. This is a great question. I think what should be removed last, the safety grounds or the lockout tagout? So Jay, you want to take a stab on that question?
Yeah, that's the lockout tagout. Basically, because if you leave the safety grounds on and you remove the lockout tagout, and somebody decides to close in that breaker, you're going to put a bolted fault on your system, which doesn't make any sense. So the last thing you want to do is remove the safety grounds. I mean, the last thing you want to do is remove the lockout tagout, because what if you're in the process of removing the safety grounds while somebody tries to close in a breaker to that circuit and energize that circuit? Well, now you're in trouble. So the last thing you want to remove will be the lockout tagout. So take the safety grounds off first, and then do the lockout tagout as your last thing to do before you re-energize.
Thanks, Jay. And the next question is, do Grace ports provide acceptable means for verifying a circuit is de-energized? I think Charlie mentioned it several times. So we have a voltage test station and also a safe test point where you can verify the de-energized state from outside the door, so you can minimize the use of PPE and such. So let's go to the next question. How to address arc flash values if the upstream protective device is over-duty? This is for you, I think, Jay.
Yeah, so the way I interpret this is how to address, say, arc flash values or incident energy calculations that are high, also when the upstream protective device is over-duty. There's a number of things that are out in the industry right now to reduce the arc incident energy or to provide an adequate protection. So the first and foremost is you could replace the upstream device that's over duty. If they don't make anything available, another way you can modify the system, such as bus splitting, putting in an inductor or reactor to lower short circuit current values. You can also install what's called a triggered current limiter, which is basically a high-speed fuse that switches in a fuse, which interrupts the fault in a quarter to half cycle, which significantly reduces the arc flash values down from, like, say, category 4 to a category 2. If it's a low voltage, like 480 and below, if you use one of those devices, it's basically category 1. There's also these devices called shorting switches, and basically what they do is, if you have an arc flash in a panel when someone's working, it'll detect that and introduce a 3-phase voltage fault in another location on the system that can actually handle the current without overduting other equipment, and it basically removes the arc flash from in front of a person over to another part in the system that can actually handle the current. And it's just a bolted fault. So there's a number of ways you can, I'd say, protect an overduty piece of equipment. It's just, what makes most sense for your application and your particular installation.
Thanks, Jay. So next question is, any specific codes mitigated by Graysport products? I can take this question. So one is you can meet the step 7 of article 120.5 for verifying the absence of voltage. That can be done from outside the door using our safe test point and voltage test station. And also, if you look at NFPA 79 and UL 508A requirements for using the utility outlets on the industrial control panels, you can use the Graysports with the GFCI inside outlets, which you can look at some of our top selling products. Those can be addressed as well on the tab. Okay. So next one, I think this is for you, Jay. What code, if any, requires the use of PPE rated attire when working 480 volts hot? And what is the best reference for help in calculating electrical fault energy?
Yeah, so to answer the first question, that would be NFPA 70E and also OSHA 1910, the regulations. Those are the two sources that we'd look into as far as PPE for 480 volt hot. As far as the second question, what's the best reference for calculating? That would be IEEE 1584, 2018 edition. If it's DC calculations, there's also some IEEE papers that go into DC arc flash versus AC arc flash. There's also the Ralph Lee method, the Dan Doan method. There's a number of methods out there, and IEEE 1584 does provide some guidance in that in the annex / appendix material.
Okay. Thanks, Jez. Next question is for you again. So what retrofit solutions are available for arc flash reduction at sites with simple molded case circuit breakers?
So I kind of just answered that question regarding the over-dutied equipment. So some retrofit solutions, there's equipment that can be installed, say, on top of an MCC. There's ways that you can modify, say, an MCC where you do some additional bus work just next door to it or adjacent to it, and then you put a device in there, and then reconnect up to the MCC. But those could be a different breaker, could be a fuse, could be a current limiting device. It could also be, say, an arc flash sensor, like a light sensor, pressure sensor, that could then help reduce the arc flash incident energy by changing the duration of the times to a circuit breaker to operate. You can even change the settings on the circuit breaker. So if it's set to 10 times instantaneous, you can reduce it to 4 or 6, as long as you don't start tripping breakers on inrush. That could also be an option.
Okay. So I think we'll take one more question. Probably got 2 more minutes. So I think this is a great question to probably conclude, if not. So what are the elements of electrical safety, and how can the electrical safety be managed from a preventive approach? I think that's a great question. Charlie, what are your thoughts on this?
Did you say we have 2 more hours to be able to cover the first question?
I think we have, but I don't think the audience has that much of time. So,
elements of electrical safety, 70E lays out electrical safety in the workplace very, very well. And it has specific direction. We have specific direction to go by for electrical safety. As far as the elements, you can go section by section, chapter by chapter in 70E. One of the biggest I talked about early today is treat all equipment as energized until it has been proven to be electrically safe, in what 70 calls an electrically safe work condition. How can the electrical safety be managed from a preventative approach? Train employees, require employees follow the requirements of NFPA 70E. The company needs to have an electrical safety program, electrical safety policy, which will incorporate the aspects, the provisions, the directions, everything that's required in 70E. Now, the company can go a step, they can go further than 70E, absolutely, but the minimum at least is to go by 70E.
That's a good answer, Charlie. I think do you also want to answer the electrical safe work approach on the same question? The safety be managed from preventive approach. How can safety be managed from preventive approach? Do you think the people, processes, or the few other things that needs to be taken into consideration? Maybe?
Yes, we absolutely, the companies need to incorporate this into their policies. They need to be active in watching any type of electrical work, and they need their people need to be trained. One of the things that I'm doing more and more in my seminars, in my training going out to industrial plants, is the hands-on aspect, which covers hands-on training, but it also covers the required work audit, the required task audit that workers, qualified workers, are supposed to go through it and be complying with as well.
All right, thank you, Charlie. I think we're right about 11:31 and we couldn't get to all the questions. Definitely, if you have any questions, please reach out to us and we'll be more than happy to respond. Again, the disclaimer I just put on the slide here on the screen. So these are basically our personal and professional responses based on our experiences. So just want to make sure that if you want any specific insights about your application or additional information, please reach out to directly with Jay or Charlie or myself. So I'd be more than happy to provide you with any other answers or help you out with those safety questions as well. So again, thanks everyone for joining our discussion today, and we'll definitely look forward to answer your questions and help you guys out in any of your safety needs. Please make sure that you do the exit service as you exit the webinar, okay? Thank you again for your time. Thanks, Jay. Thanks, Charlie. Really appreciate it.
Thank you.